All right, in the y equals square root of x squared plus 5. I need to close the parenthesis. If I don't, I could cause problems. And the next one's 1/3. I know, I'll fix it.
That's just great, Mr. Malcolm.
If you don't put it in from 1 to 6, it will matter.
It's 1, because what the calculator is going to think is 1 divided by 3, then times x cubed. It's the same thing. When I hit graph, it should be the same.
Yep.
There's your first one. There's your second one. I need to worry about right here, where they intersect at. That's the only place they intersect. Sometimes it will be more than one. So I hit second, trace, 5, flashing. That's my first curve. That's my second curve. My intersection is up here somewhere. X is about 2.968. This one's the same exact problem as the first one we did. I have that absolute value of x squared minus 4x minus 3 is equal to x cubed plus x minus 6. And this one I was looking for the intersection of both, right? What do you think I'm going to look for in this one? X-intercept. Now, in order to do the x-intercept method, I have to set this equal to 0. One of these has to be moved. So if I move one around, I'm going to have f of x equals absolute value of x squared minus 4x minus 3 minus x cubed minus x plus 6 equals 0. That's what we're going to put into the calculator. All I did was took all of this and moved it to the other side. Y2 is nothing. So when I put in the calculator, Y2 should be empty. Absolute value, so that's number 1. Now I just go, yeah, it's a long problem. Just think you're doing this in the calculator, not by hand. I type everything in the calculator. Once you have everything typed in, hit graph. I need to find the x-intercept. So I'm going to hit second calc. I want the 0. That is the x-intercept. So 2. My left bound. If I have my graph here, I know my x-intercept is right here, correct? I need to pick something to the left of this. So it's up here. Where's my x at? There it is. Anywhere over here, I can hit enter. And it should say now right bound. So you're telling the calculator a left bound is somewhere over here. I don't care where. Now you need to tell it somewhere over here. So I go past my x-intercept and press enter. It is now, you have now told the calculator my x-intercept happens in between here and here. I need a guess. Just move the little dot so it's close to the x-intercept and press enter. Looking at this, what do you notice? It should be the same answer you got before. If you don't get the same answer, you have a mistake. You're always going to get the same answer. It might be off a decimal or two, like out in the 100,000ths, different, but it shouldn't be any different. That's one way. Let me show you the other way. Okay. Go back to the 0. When I do the 0, it says left bound. All right. My x-intercept's right here. What is it about? By looking at it, it's about 2. Give me a number less than 2. 1. I just type 1 and press enter. Instead of using the arrows, I can just type a number less than that. Okay, right bound. Give me a number past 2. 3. I could use 2.5. I could use 10, whatever. The bigger the number, the farther the number is away, the longer it takes the calculator to do the work. You need to tell the calculator it's in between what and what. Now my guess. What is my guess? 2. Press enter. You get the same exact answer. You can either use the arrows to do the left and right bounds, or you can just type in numbers. Okay? Guess what's behind the calculator? Guess which one? Same one as before. I want you to try to do this one with the x-intercept method and see if you get the same exact answer. When I rearrange this, I have the square root, sorry, second squared, x squared plus 5. Close the parentheses so we don't have any issues. I move this over, it becomes negative 1/3 x cubed. Move this over, it becomes positive. I graph. My intersection's right here, which looks like it's about 3. Okay, second trace. My 0. My left bound, I'll just pick 0. My right bound, I'll pick 5. My guess is about 3. Doesn't matter how far left and how far right. My answer is 2.968, which is the same answer we got before. Either method works. Try this one. When I type it in and I hit graph, it does this. Now I'm going to zoom in. I just zoomed in. And when I zoomed in, what are you noticing? When I take it, it's going this far, it stops, and it starts up again over here. It's a technical quirk in the calculator. It will not let you solve the problem. So I have to rig the problem so it will graph it.
Why? Wait, why does it do that?
It's an error. It's something in the calculator it can't graph. The reason why, when I take the square root from here to here, it gives me errors. It won't let me graph it. You can't get around it. The calculator goes by the rules. Take out the square root. And take out the parenthesis on the end. Now graph it. But if I take it, it's the same exact graph, right? But now it's coming down. I took off the square root because if I think of this, all right, think of this as an algebra problem. How do I get rid of a square root? I have to square both sides, right? Square root's gone. Square 0. Square 0. Did it change the problem? No. So by taking off the square root, I haven't changed the problem at all. Now I can get my zeros. So if by chance you have a disappearing graph, or it's telling you no sign change, take off the special function. You might have to take off the absolute value. You might have to take off the square root. Sometimes you're going to have to zoom in and see what happens closely. Because when I zoomed originally, you really didn't see anything there. I don't have the square root. it's going to say no sign change because a couple people tried it.